This video is a brief overview of how to multiply and factor quadratic expressions. The videos which follow will describe how to do these things in much more detail, but the purpose of this video is to quickly review how to do these and kind of give you the big picture of what you're doing. So you can use this video if you remember most of these techniques and just need a quick review, or as sort of an introduction before you get into all of the other videos which are in much more detail. So to multiply or factor quadratic expressions, the rule that allows us to do these things is the distributive property. So this time we're applying it to algebraic expressions instead of just to real numbers. Okay, so here are two examples. We have in each of these situations a monomial, one term, being multiplied by a binomial, in this case a sum, and in the second example a difference. Alright, so the distributive property tells us that if we have something multiplied times a sum, then we would distribute that term to each of the terms inside the parentheses. Alright, so the distributive property says to multiply 2x times x and also to multiply 2x times 5. Okay, and then we can simplify these. 2x times x. Alright, you may remember x times x is x squared, so this would be 2x squared plus, and then we're using the commutative property here to kind of switch the order of our multiplication, and we're going to say that this is 2 times 5 times x, or just 10x. Alright, in the second example, we have a negative x being distributed, so this would be a negative x times a 3x, and then we'll do a plus sign here, plus a negative x times a negative 4. Alright, so this gives us, in the first term, this is really a negative 1 times x times 3 times x. So the commutative property lets us rearrange the order of those terms. Alright, so that's going to give us negative 1 times 3. We can do the numbers first. Right, so that'll be negative 3, and then x times x is x squared. And then the second term here, negative x times negative 4, is negative 1 times negative 4, which is positive 4, times x. Okay, and that would be your example. Alright, so there are the two answers, and the goal here was just to multiply these expressions. Your directions will say multiply. But then also just a reminder, if you do see parentheses, that sort of implies multiplication of the two things that are next to each other. So if I saw 3 times 4, that's saying multiply 3 times 4. If I see 3x, that's really a product. That's really 3 times x. So either parentheses next to each other, or just a number against a variable, or in our two examples, an algebraic expression here kind of smushed up against a parentheses. Alright, here's another example. This is a binomial, two terms, times another binomial, and we can still use the distributive property here, except in this case we have two terms, the x and the 2, that are being distributed to the x plus 3. Alright, so I need to go through and use the distributive property twice. I'm going to be doing x plus 2, right, all of this, distributed to the x, and then also distributed to the 3. Alright, and then I'm going to go back through, and I still have a single term times two terms, so I need to use the distributive property again to multiply x times 2 and x times x. And on the right, I'm distributing a 3 to the x and a 3 to the 2. Alright, so first this gives me x times x is x squared, then x times 2, that's 2x, and then on the right I have 3 times x and 3 times 2, which is 6. Alright, and then finally I have two terms here which are like terms. So they have the same variable, and that variable has the same exponent. So it's understood that these are x's to the first power, so those are like terms. All right, so I can add those, and I've got x squared, and then 2x plus 3x is 5x's altogether, and then plus 6. All right, so this would be the final answer if the problem were to multiply these two binomials. All right, here's another example. So notice in the last example, let's look at this one again. All right, really what we did, we had 4 multiplications, and notice that we really just distributed this first x to the x and the 3. Okay, that's my x squared and 3x. And then I kind of could have also gone back and done this 2 times the x and the 3. All right, so here's the 2x, and then here's the 2 times the 3. All right, so if I wanted to kind of shortcut the steps to write down what exactly I'm distributing, I could say, all right, well, I know I'm going to distribute this negative 2x to the 4x and also to the negative 5. And I'm also distributing this 4 to the 4x and the negative 5. So essentially I have 4 multiplications that are being done in this problem. And you may remember, if you've done this before in high school or another course, there is a little acronym to help you remember what you're doing for distributing, and that acronym is FOIL. Right? And FOIL stands for first, outer, inner, and last. All right, so in this case we have 2 terms which are first, and that would be the negative 2x and the 4x. So FOIL is kind of reminding you of the 4 different multiplications. You're multiplying the first terms, the negative 2x and the 4x. Right, that's the first. Then the outer, we have 2 terms on the outside. We have a negative 2x and a negative 5, so we need to multiply those. And then inner, the 2 terms on the inside would be the 4 and the 4x. And then L is for last, so the terms which are last in each parentheses would be the 4 and the negative 5. Okay, so this is just a quick, easy way of remembering your 4 multiplications, and you can just follow along the orange arrows and see that each of those 4 problems is represented in FOIL. Okay, so whatever way you choose to do this, either FOIL or the distributive property, I would go ahead and multiply those now. So first, that's going to give me negative 8x squared. Outers, negative 2 times negative 5 is 10. And I think I'm actually missing an x there. That's a negative 2x times negative 5. Okay, so that would be positive 10x. And then inners, 4 times 4x is 16x. And then lasts, 4 times negative 5 is negative 20. And then finally I would combine the 2x terms in the middle. So final answer is going to be negative 8x squared plus 26x minus 20. Alright, so let's talk about the connection between multiplying and factoring. And again, these 2 concepts will be described in much more detail in the videos which follow. So this is just intended to be a fast explanation of how to do each of these things and the connection between each of them. Alright, so if you had an arithmetic problem like 3 times 4 equals 12, if you were asked to multiply, right, so if you have 2 numbers, makes sense, you know what you're supposed to do. 3 times 4, we would multiply those together. That would be the problem. And then the answer would be 12. Okay. Now, if your problem was to factor, you might be given something like the 12. That's your problem. Right? And then your answer to factor would be to find 2 numbers or multiple numbers which multiply to be that 12. So it's almost like we're dividing the 12 or finding those smaller pieces which are factors of 12. All right, so we could factor 12 in a number of ways. I could say that 12 is 1 times 12. I could say that 12 is 2 times 6. I could say 12 is 3 times 4. And then, of course, I could reverse the order of all of those. For example, 4 times 3. And then I might also have to consider negative numbers. So I could do negative 3 times negative 4. All right, and a couple different combinations there. All right, but one thing to notice is that for factoring, we can factor 12 uniquely if we factor it down to prime numbers. Right, so notice that 12 is 2 times 2 times 3. So if I wanted to use prime numbers, there's really no other way to write 12 other than 2 times 2 times 3. Right, I could switch the order of those, but that's about it. All right, so when we get to algebraic expressions, let's kind of take those same techniques and apply them in this situation. All right, so to multiply, same idea, you just have a different, kind of a longer process with the distributive property, but the idea is that you are multiplying two smaller pieces together to get a larger product. All right, so in this case I would do, we'll do FOIL again. All right, multiply the firsts, x times x is x squared. Then outers, x times negative 3 is negative 3x. Inners, 5 times x is 5x. And then last, 5 times negative 3 is negative 15. Okay, and then finally just simplifying, I've got two like terms that I can combine. So x squared, negative 3 plus 5 is positive 2x minus 15. Okay, so now for factoring, in this case, kind of just the problem and the answer are reversed. So you would be given something like x squared plus 2x minus 15, and then your goal here is to work backwards and find those two algebraic expressions which were multiplied together to give you x squared plus 2x minus 15. Right, so there should be, just in the same way as there are only one set of primes that multiply to be 12, there's only one combination here of kind of, you could think of this as like the prime factors that are going to multiply to give you this expression. All right, so we just need to work backwards to figure out what those are. I'm looking for 4 different terms here. And same idea, kind of using FOIL. All right, notice I got this negative 15 from multiplying in my original expression negative 3 times 5. All right, so what I'm trying to do is find two last terms which would multiply to be negative 15. And I do have a couple options. It could be 15 and 1, it could be 3 and 5, and then it could be, you know, 1 negative and 1 positive, but I don't know which is which. All right, so right now I'll just take a guess, and I'll try 3 and 15, or I'm sorry, 3 and 5, and I'll see if that works. All right. Now my first terms, okay, so we usually start with kind of the firsts and the lasts, and then we go back for the outers and inners. All right, so my two first terms need to multiply to be x squared. All right, so I'm trying to kind of break this down into simpler factors. So I would never really want to have like an x squared and a 1. Instead, I'm always going to factor x squared as an x and an x. All right. And now this does fill in the outers and the inners, but what I need to check to see if this is correct is when I kind of go through that process of either distributing or using that FOIL acronym, do the outer and inner terms add up to be this negative 2x? Because if not, then I have the wrong combination here. All right, so let me try something first. I will put in, I'm going to do a plus 3 and a minus 5. I know I need one positive and one negative because these were supposed to multiply to be negative 15. All right, so let me try that one. All right, so if I go through and use FOIL or distribute to check this, I'd do x times x squared, so that's the first two terms. All right, The last terms, 3 times negative 5, that's negative 15. Okay, and we're good so far. All right, and then the inner terms, 3 times x is 3x. And then the outer terms, x times negative 5 is negative 5x. All right, so good so far. But now when I go to combine like terms, I have 3x minus 5x, which is negative 2x. All right, so this is incorrect. And I know that it's incorrect because I wanted a positive 2x. Right? So what I would need to do is just go back and make adjustments until I have the correct combination of numbers that work, right, for whatever it is that I wanted. So in this case, I can kind of see that my negative 2, I want that to be positive instead. But the number is correct. So I like the 3 and the 5, but what I want to do is just switch these two symbols and make this a negative 3 and a plus 5. So then at this step, I'll have negative 3x plus 5x. And that's going to work. That's going to give me positive 2x. Okay, so that's just a brief overview of the connection between multiplying and factoring. This was very quick, but there are videos which follow which describe this much more slowly and in more detail in case you're not familiar with these concepts.